In this video, we're going to look at how to perform calculations involving the masses and moles of a substance. So often in chemistry, we have to convert the mass of a substance into moles or atoms of that substance. And there's a general strategy that we can follow to help us with that. If we're given the mass in grams of an element, we can convert it into moles of that element using the molar mass. If we have moles of an element, we can find how many atoms there are using Avogadro's number. Now we can also go in reverse. We can go from atoms to moles and then from moles to grams. The only thing we can't do is go directly from grams to atoms or vice versa. So generally when we convert from grams to atoms or anything, we generally have to go through moles. Now this strategy follows whether we're talking about atoms or elements, or whether we're talking about compounds. So what we want to do in this video is give you some practice problems to help illustrate this strategy and help you be able to perform these calculations. So let's start right off with a problem. What is the mass in grams of 7.53 moles of gold? Now you're going to need to get a periodic table for these problems. Solve them using dimensional analysis. Show your units and your work. Pause the video and give this problem a try. Okay, so we're starting with 7.53 moles, and we want to convert it into mass or grams. So we want to use the molar mass as our conversion factor, and we want to go from moles to grams. Now, to do this, we need the molar mass of gold, which we can get off our periodic table, 196.97. So here, I'm starting with the moles. This is what I'm given, and I want to use the molar mass. My strategy says use the molar mass to convert it to grams. I'm going to write the molar mass as a conversion factor. 196.967 grams of gold is equal to 1 mole. I want the moles on the bottom so they cancel. And I multiply these two in order to figure out the mass. Now, all of our numbers must be to the correct number of sig figs. This has 3. This has 6, so my answer will have 3. So 1,480 grams of gold is equivalent to 7.53 moles. Let's try another one. Again, get your periodic table. Use dimensional analysis to solve this problem. Pause the video. Okay. So we're given the mass in grams and asked how many moles do we have. Let's look at our strategy. If we're given grams and we want to go to moles, well, we need the molar mass, in this case of chromium. That's going to be our conversion factor. Looking at our periodic table, we see the molar mass of chromium. So I'm going to write down what I'm given, the grams over 1. Now I need to use the molar mass as a conversion factor. 51.996 grams of chromium per 1 mole. Moles on top. I want grams to cancel, so I put grams on the bottom. And if I multiply these two, I'll figure out how many moles of chromium I have. Again, to 4 sig figs in this case. 3.441 times 10 to the minus 4 moles of chromium. So these two numbers are equivalent. If we have this mass of chromium, this is how many moles we have. Okay, let's try a couple more. Pause the video and give this one a try. Okay. So how many atoms are in 2.99 gram block of copper? Well, let's figure out our strategy. We're given the mass in grams of copper, and we want to get over here to atoms. So we have to first convert the grams into moles using the molar mass of copper as our conversion factor. Once we have moles, we use Avogadro's number in order to convert the moles into atoms. So let's get the molar mass of chromium from our, of copper from our periodic table. Now, let's set it up. 2.99 grams of copper. We're going to start with that. We're going to first use our molar mass with grams on the bottom, so the grams cancel, is equal to 1 mole. Now, The second step, we need to use Avogadro's number. 1 mole of copper contains 6.022 times 10 to the 23rd atoms. We want moles on the bottom, so moles cancel, and we'll end up with copper atoms. Again, be sure you use the correct units here. We multiply the 2.99 times 1 times Avogadro's number, divide it by 63.546, and to 3 sig figs, we get 2.83 times 10 to the 22nd copper atoms. Okay, let's keep going. Let's try another one. Pause the video and give this one a try. Okay. So here, what is the mass? So we're given 7.22 times 10 to the 24th molecules of water. What is the mass in grams? So we want to convert our molecules into moles using Avogadro's number as our conversion factor, and then moles into grams using the molar mass of water. Molar mass of water, we get hydrogen times 2, oxygen times 1, add those together. So we take our molecules that were given, and let's convert that into moles. 6.022 times 10 to the 23rd water molecules is equal to 1 mole. We want molecules of water on the bottom. Again, write your units, don't skip that. Is equivalent to 1 mole, with moles on top. Now we use the molar mass to go from moles to grams. The molar mass of water, 18.015 grams, is equivalent to 1 mole. We put moles on the bottom, grams of water on the top, and that should get us the mass in grams. Multiply everything on top, divide it by what's on bottom, and we get 216 grams of water. So 7.22 times 10 to the 24th water molecules is equivalent to 216 grams of water. So be sure you can perform these calculations readily, understand the strategy, and be able to convert from grams to moles, moles to molecules, or vice versa.